Welcome to the AI Ireland podcast, your window into the world of AI innovation on the island of Ireland. Join us as we explore how AI is harnessed to tackle both business and societal challenges, revealing the cutting-edge solutions emerging from this vibrant AI community. Don't forget to subscribe for the latest updates and insights in the world of AI. Hello everyone, you are very welcome to the AI Ireland podcast, and today we've got a guest that we should have had probably about 6 to 9 months ago, but for a variety of different clashes and diaries, we weren't able to actually have the episode. But I'm delighted to be speaking to Ciarán Gilligan-Lee. He was nominated for AI Person of the Year in 2023, and he's head of Causal Inference Research Lab at Spotify. He's also an honorary associate professor at University College London. Ciarán, thank you so much for joining us on the AI Ireland podcast today.
Thanks, Mark. Yeah, really happy to be here.
Would you mind just briefly telling us about some of the work that you're doing at Spotify? I think everybody in the world will probably know Spotify to some degree, but they may not know that AI actually plays a really big part in the music that people listen to day to day.
Yeah, absolutely. So the team I lead at Spotify works in an area called Causal Inference. So it's kind of a toolkit that lets us understand cause and effect. We've all heard, correlation isn't causation. When we look at all the data we might have on the types of tracks or podcasts or audiobooks that, people like to listen to, and, if they found a new one, they'd listen for longer and so forth. All of these are correlations. And so if we want to somehow extract from all this information the right next decision to make, the right next track or podcast or audiobook to recommend to a user to keep them enjoying Spotify, to help them discover new music, then we need to understand, what's causally underpinning what's going on, or what's really causing them to enjoy that piece of content, rather than just saying, oh, I love Spotify, so I'm just going to be on the app more than average. And because I'm on the app more than average, I have just more time to listen to things. It may not be that those additional things are really increasing my enjoyment of those new pieces of content, or helping me discover new music and new creators and so forth. And so if we understand, causal underpinnings of these things, we can make better decisions and improve the experience for both our users and our artists, right? Because we can help them find and increase their audiences.
Yeah, and everyone wants that, because if you have that more personalized experience where you get me, or you get the context of why I want the music to be played, because we've all got different reasons to have different music on at any time, genre, artist, wherever that might be. And you've done some interesting research in this yourself. It'd be great just to hear a little bit more about that, and also how people can sometimes confuse the different terminologies in there.
Yeah, absolutely. So some of the kind of recent research we've been looking at is ways in which to find the right, let's say, musical track for someone at a given point in time. So usually we just kind of say, okay, if we had a big set of information or data telling us, okay, these types of people stream these types of tracks and they seem to enjoy them and so forth, we could just do the standard machine learning classification style problem, right? Given that you streamed, what's the probability of you streaming similar content like that in the future and so forth. But if you kind of change your perspective on what types of information we're kind of given, and you ask what's called a counterfactual question, so it's a causal question nature, and you ask, okay, given that they did listen to this, if we had instead at that point recommended them a different piece of music, would they have enjoyed that as much? And if we can understand that, then we can understand what to offer them next. Or if we can say, did this user stream this content because it was recommended to them, or would they have found that content organically? Maybe they like the artist, they would have searched for that artist's new album anyway, and us recommending or promoting that track to them would actually just annoy them. They wouldn't really like that. They want to find it organically. So if we can understand the counterfactual nature, would they have found this content without us promoting, then we can understand when is the right time to serve a new piece of music to a user, and when is the time that we should let them kind of organically explore themselves to enjoy their experience in a bit more of this kind of organic fashion. So the work we've been doing is how to actually answer these counterfactual questions. They sound strange, right? You have factual data, observations. How can you make inferences about what could have happened in different sets of circumstances? Had we shown a different track, different podcast, and so forth? And so we kind of relied on this toolkit of causal inference. We came up with some research on how to combine some of the kind of algorithms in there with some deep learning architectures, so that we could really scale these to the kind of the level of people and data that we're dealing with on Spotify, which is huge. And then, we published our research in Nature Machine Intelligence. We got some press at MIT Tech Review. And so, the great thing about Spotify is they're always looking to kind of push things, hit the cutting edge. If there's a better way to do something, then they're going to try it because that might bring, you know, a little bit of an edge in terms of people's enjoyment of the app and so forth. And so it's something that they're, you know, seem to be quite passionate about and something that they value. There's a lot of different research labs at Spotify, and they all work on different aspects of these types of problems. So it's an exciting place to be.
Yeah, because when you think of it like that, it's creating that experience that you just don't want to go anywhere else. And Spotify has definitely been a leader in that from the music and the podcast perspective. And that user experience becomes very, very important. How do you stay away from the spurious correlations or the kind of rabbit holes that you may think is important, but actually is not necessarily affecting the outcome?
Yeah, absolutely. So this is like the main difficulty and trick with kind of causal inference, right? It's really trying to understand the data generation process in a deep way. So there could be these variables which are called confounders, right? Which influence both, let's say, somebody's willingness to stream a new piece of music and whether they will then stream that again in the future. And so it could be nothing to do with how much they enjoyed the content that would make them stream again in the future. It could be other factors such as, you know, the mood they were in that day. They wanted to listen to, there's like lots and lots of, let's say, lo-fi music, and they're going to keep streaming even though maybe the quality of the track isn't something as big as, say, you know, a new release from Taylor Swift or something like this. Or they could, you know, be big fans of Spotify and they're on the app more, you know, that they show a willingness to kind of keep coming back and listening. It's nothing necessarily to do with the thing they listen to, just that they like listening to music in general. So there's loads of these factors that come into play, you know, the type of user they are, how often they listen to music or podcasts anyway. And so if you can kind of list a good collection of all these kind of factors, you can try and control for them. So say, okay, well, some of the reason they might come back is maybe due to the context of the mood they're in that day, or how much they like Spotify and various other kind of factors. And some of it is due to the content itself, right? Maybe they discover a new artist and they're like, oh, I really love this artist. I'm going to listen to them really intently over the next week or two. And so if you can disentangle all these different factors that are at play, you can tease apart, okay, if I now recommended this new content, how much would that change above and beyond this person's organic inclination to stream in this context anyway? So if you can understand these kind of causal factors correctly, then you can understand how to make the right decision by saying, if I change this, but keep all these other factors the same, I now know what will happen as a consequence. So that helps reduce kind of spurious correlation and helps us really like have good confidence that actions we take will have the desired outcome. Of course, it's hard to be kind of sure of this in principle, but we do lots of experiments, lots of A/B tests to kind of clarify our thinking and gain confidence and so forth.
When you think about some of the assumptions that you may go in with the team on, and then you're challenging those assumptions, how do you kind of stay true to kind of a level playing field where you've got your opinions and your perspectives, but then you kind of mentioned that A/B testing, but you're kind of coming at it from a kind of a bias-free approach?
Yeah, it's definitely tricky. You know, there's a huge range of problems we're trying to work on at Spotify to improve our recommendations, our user experience, and kind of so forth. And it's tricky as part of that because you're dealing with many different stakeholders and teams, product teams that have various kind of, you know, perspectives and requirements, machine learning teams that have a certain way of kind of trying to solve these problems and so forth. And you're trying to like meet people where they are, explain, you know, the types of things that could be unlocked if we're able to use these new tools. And moreover, you know, A/B testing is great and it's really kind of the backbone on which we can make, you know, accurate decisions. But some of the time we can't do A/B tests for, you know, various reasons. It could be the new test perhaps is too damaging to the user experience, and so we can't really run it. Like if we wanted to understand, you know, hypothetically, if app crashes were a cause of churning, so people not coming back to the app because they were frustrated that it kept crashing, it wouldn't be reasonable for us to do a test where we randomize people into a group and said, we're going to kind of crash your app and just see what'll happen. If we think it's going to have a bad effect, we shouldn't probably do an A/B test of that form. But if we can build a causal model, in some sense, we could simulate what might happen based on data that has already occurred. And from that, we could then make a decision even without having an A/B test. And so it's trying to come to a kind of place where everyone understands everyone's perspectives, the requirements and the needs, and then collectively trying to say, okay, could we increase our, you know, efficiency, our accuracy by, you know, having this little bit of research in there that would improve things. And it's it's a kind of continual process and trying to get everyone on the same page and move things forward. But there's definitely a willingness for that to happen and to incorporate state-of-the-art kind of approaches in these discussions.
And when you're kind of doing that, are you kind of creating like an assumption log where you're listing your assumptions as a collective team, and then you're kind of scratching them out as it comes, because everyone's got different values, different ethics, they come from different perspectives? Is that too simplistic in terms of approach?
No, I think it's right. I mean, it takes a lot of work to get to the level where either we'd be running a test to check, some sort of well thought through set of assumptions and hypotheses. And it takes a lot of, testing on observational offline data that we already have to kind of, as you say, okay, here are all the possibilities now for things that could improve, this model or this system that we're working on. Let's try a good collection of them on this offline data, see which ones are doing better than the other ones. From that, we then got to get a good candidate list of things we'd actually like to test in an actual experiment. And then, the process is kind of quite gradual in this way, where we have many meetings, we're coming with documentation, figuring out all the kind of next steps and the things we should check until we get a well-honed kind of list. But the great thing about causal inference is that to do any of the modeling, to kind of create causal models, you have to be really, really clear on what the assumptions going into the model are, what the variables are, what potential sources of bias could be, and so forth. And this process kind of forces everybody to get on the same page and to really list assumptions that maybe in standard machine learning approaches would be implicit in the modeling process and so forth, and really forces you to think clearly about what's going on. So it's like an added benefit before you even get to the improvement in accuracy and so forth.
And when you think about it outside of music, is there any other interesting industry sectors or trends that you think this could be applied to?
Yeah, absolutely. I mean, to me, whenever you're making a decision, you should be using causal inference. Before I started at Spotify, I worked at a healthcare startup in London, and there they had this chatbot that would interact with a patient, try and understand symptoms that they might be displaying, and then try and triage them. So say, okay, I think you should go to the emergency room, or you should go to see a GP, and so forth, because the model underlying this chatbot was a big disease model that kind of tried to figure out, okay, what disease was likely in the situation, and then from that, what you should do as a consequence. But the way this model was working was very similar to kind of approaches in medical AI that go back to the 1980s. That is to say, it was using correlations to try and figure out what was going on. So it's trying to say, okay, well, given all these symptoms that you might have, what's the disease with the highest correlation with those symptoms? What's the disease that's most likely under this evidence that I'm kind of seeing? But in certain situations, this led to kind of wrong results, because you can have situations where a disease is highly correlated with the symptom, but it actually doesn't cause it. So one example we found was, if somebody comes in and they're saying, they have shortness of breath or chest pain, in that situation, there's a large part of the population where those symptoms are highly correlated with being overweight. And if you belong to that part of the population, then again, with some probability, you might have type 2 diabetes. And so by virtue of this link between chest pain, being overweight, and diabetes, there's now a correlation between type 2 diabetes and chest pain, but there's no causal link between those two things. So if we were to say, oh, you should maybe take some insulin that will reduce your type 2 diabetes or make that more kind of manageable, but that won't have an impact on your shortness of breath or your chest pain. And so even though there's a correlation, the decision that would have been recommended based on that would have been the wrong decision. And so we kind of ended up building a causal approach to do this kind of diagnosis problem, to try to find the disease that's causing your symptoms, and from that, improve diagnosis. We actually did a test that was published in Nature Communications a couple of years ago of the causal approach to the standard correlational approach, which is based on normal machine learning, to actual doctors and how they would diagnose patients in these situations. So we gave them all kind of case studies. Here's the history of this user, here's the symptoms they're displaying, and here's the disease that is the likeliest cause in this situation, and try to see from the patient's background and their symptoms, could the doctors infer what that disease was. It turned out that the causal approach was pretty much on par with the best doctors, whereas the correlational approach was in the kind of bottom half of doctors. So it really improved things. So healthcare is definitely a big one. Drug discovery, there's lots of kind of pharmaceutical companies that have big causal teams. All the big tech companies, Amazon, Facebook, Google, have big causal inference teams, both for terms of understanding what decisions they should take, but also trying to incorporate them into their deeper, more fundamental machine learning technology. So for me, causality is like a kind of fundamental tool that helps you just improve your decision making. So it should be applied pretty much across the board.
Yeah, and we want to have better data, better insights to make better decisions or that next best action. And if we're doing that, we'd feel a lot of peace of mind rather than making decisions where we got limited or not all the information. And that's ideally you want that kind of one source of the truth.
Yeah, absolutely. I mean, it kind of happens routinely that even with the best intentions, you can kind of miss bias that might be present in your data. And then if you're basing your decision on this data, then you could lead to kind of wrong decisions. There was an interesting example that I saw a while ago, around the time of the kind of COVID vaccine rollout. The National Office of Statistics in the UK was publishing kind of mortality data for the groups that had been vaccinated versus those who hadn't. And a weird kind of finding was emerging, even though we had randomized control trials that showed us that the COVID vaccine reduced mortality rate, in the observational data, just looking at the population who had vaccine, who didn't, what their mortality rates were, people with vaccines were more likely to die than people without vaccines. So it seemed very counter to what was going on, right? It didn't seem like it agreed with these randomized control trials that we have done. And it turned out that in this case, because of the way the vaccines were rolled out, there was bias in that data. So people who were most at risk were given the vaccine first, because people were, people maybe older than people who are, in their younger ages and were offered the vaccine at a later stage. So any improvement in mortality from the vaccine was swamped by these other causes, by these age-related effects and kind of so forth. And that's what the reason why they had increased mortality. Actually, when you controlled for age, when you bucketed it and said, okay, we look at each age cohort separately, the trends flipped back to what you would have expected from the randomized control trial. So those are the vaccines that lower mortality rates. But if we had just seen that data and said, oh, wow, the vaccine rollout is not working, we should stop it, it would have been the wrong decision because it would have led to actually worse effects in the long run. And so, even though the best intentions are there collecting the data to make decisions, you really need to think about what's generating the data, what the underlying process is in the first place, to try and do your best to tease apart, possible sources of bias to then improve your decision making.
Yeah, and again, this could go on for hours, this discussion, but as you rightly said, you just have to be really, really careful what the underlying data is showing, taking into consideration the outliers and the bias, and then trying to make sure that it's a trusted party that is sharing the results as well, because so much information, you don't necessarily know how it's been skewed and who's been involved in that too. So it's having that awareness. Well, I'm for one, Ciarán, looking forward to the updates that are coming down the track with Spotify and how this is going to be applied from a user experience in the coming months. And thank you very much for your time today.
Great. Thanks, Mark. Great to chat as always.
On the 26th of November, join us for the 6th Annual AI Awards at the Marco Hotel in Dublin. This year's event promises to be our largest and most impressive yet, with over 300 community members in attendance and over 48 applications of AI in action. This truly is an incredible world-class event, and we are inviting you to this event. Experience the excitement live, because we're going to be capturing this with a world-class film crew, and it's going to be streamed online. However, if you want to join us in person, book your table now, because opportunities are limited. If you're interested in sponsoring this year's awards, please contact me at Mark@AI Awards for more information and see the best in class of AI applications on the island of Ireland.